Teach you what might be a new technique for you. It is one of those things that you're going to use throughout your science classes, and it's really a math skill, so that's why we teach it in math class. But it was one of these things I learned in physics, but it was very useful to me throughout college. So I'm going to teach it to you now. I also talked to Ms. Conley about it, and she suggested that I reiterated this in math because they really need their students in science to know it very well, and that's teaching a certain way to do unit conversions. So in America, we use the British system of measurements. So when we consider how tall we are, we consider how many feet and inches tall we are. When we consider how far away our house is from school, we consider how many miles away. Whereas if we lived almost any other place in the world, we would consider how many meters tall we were, how many kilometers away we lived, how many kilometers per hour we were driving. We would have gas in liters. We would have temperature in Celsius. Everything would be measured in the meter system. We use the British system, and in England, they don't even use the British system anymore. Okay, there are only two other countries that I know of that use the British system, and one is, I believe, Liberia. It's hardly anybody else. So we need to know how to convert. And this method is something that we are going to insist upon in the math and the science department because it always works, okay? So we're going to use it with very easy problems, and then we're going to blow it up to harder problems. The easy problems, you might be wondering, like, why would I use this method? But then when it gets harder, it's really the only way that it works. So the way this works is we treat unit conversion factors such as how many feet there are in a yard. That gets treated as a number instead of as an equation. And the way we write it as a number is we write it as a fraction. So we write it as 3 feet per 1 yard. And this is worth 1 because there are 3 feet in 1 yard. In other words, 3 feet is equivalent to 1 yard. And if you divide a value that is equal to another value, you get 1. Like 7 divided by 7 is 1. 3 feet divided by 1 yard, is 1 because 3 feet and 1 yard are equivalent. All right. So in order to do this unit conversion, convert 6 yards to feet, the way you start off is just by writing down the given amount. So 6 yards is given. And then what we're going to do is either multiply by the conversion factor, or we're going to multiply by its reciprocal. And the way we determine whether we multiply by the factor or by its reciprocal is we have to get the yards to cancel, and we have to have feet in the numerator. So in this case, if I keep the conversion factor as it is and just multiply it as it is, 3 feet over 1 yard, then, do you guys see? The yards cancel because yard over yard, numerator over denominator cancels, and then all I have left is feet, and feet is in the numerator. And so all I need to do now is multiply across, and I get 18 feet. Now, if you were to tell me convert 6 yards to feet, in my head I would just do 6 times 3 is 18. But again, we're going to blow this up to much more complicated problems. So the whole central fact of this is that we're taking these equivalencies, we're writing them as fractions, and then we're treating them as numbers. So they get multiplied. The units are canceled just like numbers. The yards get canceled. Okay. So, questions so far?
So with the 6 times 3 equals 18, the 1, 2 cancels out, right?
The yards cancel out.
Oh, so
That's just less.
And then I was talking about the 3 feet over 1 yard.
So-
So the one would just be,
It's like 18 divided by 1.
oh,
So if you guys, I asked you to get your books out. If you can take a look at the back cover of your book, in the lower right-hand corner, they have common conversion factors from English, again, we use the British system, to metric conversions. You really aren't going to be expected to memorize any of these. They will be given to you. And so if you look, it asks to convert 12 miles to kilometers. So looking under the English to metric conversion, 1 mile is 1.609 kilometers. That is at the bottom of the first column of our English to metric conversion. So in order to utilize that, I'm going to write it as a fraction. 1 mile over 1.609 kilometers. When you write miles, if you're going to abbreviate it, just make sure you don't stop at the M, because M is meters. So we're going to start by writing the given amount, 12 miles. And I can keep the conversion factor as it is, or I can flip it upside down. So Maggie, would I keep it as it is, or would I need to flip it upside down? You guys don't need to turn around and look at her.
Okay, I'm sorry, what's the question?
So there's the conversion factor over there in blue.
Yeah.
So would you keep it as it is, or would you flip it upside down with the goal of canceling miles and having kilometer be your answer?
No.
So miles is in, I'm not asking anyone else. Miles is in the numerator here. Where would miles need to be in order to get it to cancel with this miles right here?
Oh, yeah.
You do have to flip it. Good. So the key is you need one of the units to cancel. So I'm going to flip this upside down. So when I flip it, now we have miles over miles, and then I can cancel miles just like I could cancel 2 divided by 2, or 8 divided by 8, because miles over miles cancels. And so now, that's why I asked you for your calculators. You're going to calculate 12 times 1.609.
got you.
What'd you get?
19.308.
And what are your units, Logan?
What do you mean? Oh, kilometers.
Excellent. So the name of the exercise is converting units. So your answers must have units. That's the point of it. So when it says to convert from miles to kilometers, the kilometers has to be in the numerator. If you had kilometers in the denominator, you wouldn't be calculating a distance anymore. You'd be calculating, I don't even know what that would be. So, questions on that? Okay, now we get to where this really becomes a necessity, where you just might not have needed that before. So we're going to calculate how many miles per hour, well, in this case 60, would become how many feet per second. So the first thing you're going to do is discover what unit conversions, what conversion factors you need. So miles is a distance, and you are converting miles to feet. And if you look at your conversion factors, it might not be listed here. So this might be something that you're going to have to add to your notes to have on hand. Does anyone know how many feet there are in 1 mile? Logan, you are 6 foot tall, right?
Yes.
If there were 17 feet in a mile,
It's a joke.
it's a That'd be a very tiny mile.
Oh my god.
Okay, so we need two conversion factors. We're converting distance, miles to feet, but we're also converting time. We're converting hours to seconds. So if we're not sure about the distance conversion, how about, what's that? Yes, excellent. So there are 5,000.
I forgot the number.
Okay, so again, this you're gonna wanna maybe star or highlight so you can reference it later. There are 5,280 feet in 1 mile.
That's a lot of feet.
Now, we not only have to convert distance, but we have to convert time. So this is something that, given our knowledge of time, how many seconds in an hour?
Oh.
Seconds in an hour.
How many seconds are in an hour?
Yeah.
Is it in the 200,000?
Darn. Is it 36?
Isaac. Yeah, there are 3,600 seconds in an hour.
Look at that.
So Isaac, what operation did you do?
60 times.
Good. So we have 60 seconds in a minute, 60 minutes in an hour. So we need those two conversion factors. So if we are converting 60 miles per hour, what is 60 miles per hour? What is that measuring? Right, so what would that quantify? What would we call that? Like miles is a speed, hours is a time. What's miles per hour?
Oh,
Maggie?
label. Measurement? I don't know.
Of what? It measures what? So miles measures distance,
Yeah,
hours measures time. What does miles per hour measure?
per hour.
Speed, yep. So you could call that speed or velocity. Velocity probably in a science class. Speed is the, well, you'll learn later, but speed is always a positive quantity. So watch how I set up this particular problem. I'm going to write down 60 miles. Per means essentially divided by, so that's per 1 hour. So be sure you are lining up your fractions vertically, not side by side. The vertical is going to be very important. Now you're going to use both of those conversion factors. And again, your goal is feet over seconds because it's feet over seconds. So I'm going to look at my very first conversion factor. So Logan, that red conversion factor, do I multiply by that or you guys don't need to turn and stare at me. Do I multiply by that conversion factor or do I flip it upside down?
You have to flip it. No, you multiply by that.
No, why do you say that you multiply by that?
Because if you did 60 times 1, that really wouldn't make sense.
Okay, so in terms of units, we want the miles to cancel out. Yeah, so there are two reasons why you would keep it the same.
So, because you want the miles to cancel out and...
Yep, that's one reason. You want the miles to cancel out. And what's the second reason? Talisa? I'm sorry, what? Can you talk a little louder?
So it's because that 1 mile equals that many feet?
It does, but why did I choose to keep this conversion factor as it was instead of flipping it upside down? That's my question, Teresa. So one reason is to get the miles to cancel. And to get the miles to cancel, you do need 1 mile on top and 1 mile on the bottom. But what is the other reason? Isaac?
Maybe you want to keep the time on the bottom. So
Right, but we haven't really dealt with time yet. So that will come into play very shortly. But take a look at the answer. Do you guys see how the answer has feet in the numerator? So we want feet in the numerator. Okay, so everybody look forward. You guys are losing your focus here. Feet is in the numerator right here, and feet is in the numerator in the answer. So that's why you want to keep it the same. If we were to flip it upside down, feet would go to the denominator. We don't want feet in the denominator. We want to keep it in the numerator.
So when you're doing it, you always want the feet on top.
Well, it asked for it. It said miles per hour to feet per second. So feet per second. So it will tell you exactly what you're going for. Isabel?
So then you'll have to put
You do, yes. So that's why I wrote this conversion factor right here, because I have to convert the hours to seconds. So I use that conversion factor. And so, Talisa, the second conversion factor, do I keep it as is or do I flip it upside down? The blue one. So we used this conversion factor. Now I have to use this conversion factor. Do I keep it as it is or do I flip it upside down? Okay.
Oh, flip it.
Okay, so why? You're just guessing.
It's
So,
on the bottom.
because what's on the bottom?
Yes.
Yeah, so if you look at your answer, seconds is on the bottom, so you want seconds on the bottom. Currently, seconds is on the top, so you need to flip it over.
Alright. So then it would be that times that times that.
Yeah.
Yeah. Well,
Ah.
why don't you wait?
I'm understanding this. Semi.
Okay. So you list the conversion factors that you're using. I like to list them off in the margin. This is like the margin. And then I have a string of a multiplication of all the different conversion factors that I'm using. So again, what you're looking for is that your answer has the correct units.
Awesome.
And you're looking for cancellation. Do the hours cancel? Yes, you have hours on the bottom and hours on top. Now, before I do any calculations, you guys look at the numerator. What is the only unit left in the numerator? Feet. What is the only unit left in the denominator?
Seconds.
And look at what I'm going for, feet over seconds.
I'm understanding more.
Okay. Now, when you go to do the calculation, and again, our goal is to get these graphing calculators in our hands, this is what you're going to type in. Parentheses, 60 times 5280. Those are multiplied because those are in the numerator, and then we divide by what is in the denominator. Now, since there's only one number in the denominator that's not 1, okay, 1 times 3600 is just 3600. I need a parenthesis around both the numbers in the numerator because there are two quantities in the numerator that aren't 1, and then divided by the denominator. Now, if I had two different numbers in the denominator that weren't 1, I would need a parenthesis around the numbers in the denominator, but I do not. That's why the 3600 doesn't need a parenthesis. Okay. What do we got?
316.
Yay.
Oh, for the whole thing. I thought you were talking about like. I thought you were talking about 60 times.
Right. So when you're thinking about how to act to people, just don't be a jerk. Be ruled by that mantra. Okay. 88, and you have to list the units. Feet is the only thing left in the numerator. Seconds is the only thing left in the denominator. 88 feet per second. Any questions? All right. So again, this is why the unit cancellation is important. This is why writing these as fractions is important. Okay. Let's do another one. So we have a very famous Olympic athlete. This is Usain Bolt, and he was the fastest man in the world up until very recently. And he won the Olympics at the 100 meter in 9.81 seconds. And I was very curious as to, if you were driving a car, how fast would you have to drive that car to keep up with him? All right, so he was 9.81 seconds, 100 meters. Any ideas? Any guesses?
It's a
Yep,
26 miles an
26 miles an hour. Anyone else have a guess? Yes?
27. 7.
Or
Or 28.
29.
29?
Definitely not 30.
All right, so we are going to calculate it. So currently we have our units, or does anyone else want to make your guess?
It's only like
31,
There's nobody that,
actually 24.
24,
I'm gonna say, it's either gonna be 26 point something or 27.
DJ?
27.
So you guys are all in the roughly the same neighborhood.
44.
So we're calculating speed. Speed is distance over time. So we're going to first write down Usain Bolt's speed. So again, this is given information. The amount that he ran is given, how long, and how much time. He ran 100 meters in 9.81 seconds. So to calculate how fast, it's distance divided by time. So whenever you say miles per hour, that's the distance over the time. And we want to calculate how fast in MPH. MPH is an abbreviation for miles. Per means divided by, and then hour. So we're going from meters per second to miles per hour. Meters per second to miles per hour. So again, we need two different conversion factors. We need to go from meters to miles. That is our distance. And then again, we need to consider hours to seconds. So over here, we're going to consider, does anyone see a conversion between meters and miles in their textbook? Charlize?
The closest thing we can get to meters is meters. That's what
Okay, and how much?
I see. 1 mile equals 1.609 kilometers.
Okay, 1 mile equals 1.609 kilometers, which means 1,609 meters are in 1 mile. And as we discussed before, there are 3,600 seconds in an hour. So our starting information, and this is what our goal is right here. Our starting information is 100 meters and 9.81 seconds. And so again, I'm going to ask you a similar question. So Isaac, with this first conversion factor, do you keep it the same or do you have to flip it over? So this is our starting information right here.
Oh, okay, I thought it.
So what do we do with it?
Okay.
Okay, you do have to flip it, that is correct. And let me show you why. So the reason why you need to flip it, reason number one, the meters need to cancel. Do you guys see this? Meters over meters. If you don't have one on the top and one on the bottom, it's not going to cancel. Reason number two, when you look at your desired answer, miles is on top. So you want miles on top. All right, so two different reasons. Okay, now neat, let's take a look. Right here, would you keep this the same or flip it? Okay, so if we flip it, the seconds are going to go to the bottom, and the hours will be on top.
Oh, no, you keep it the same.
You do keep it the same. All right, now again, the final check to make sure you made those decisions correctly, whether to keep it the same or flip it. One final check is do my units cancel? Now you can start crossing stuff off and it's like, okay, great, they cross out. Isabel? What's that?
The 2 seconds.
Yes, because you have seconds in the denominator and seconds in the numerator. What else cancels, DJ?
The meters.
Okay, because you have meters in the numerator, meters in the denominator. So you cannot just randomly cancel. You have to have 1 in the numerator, 1 in the denominator. So the resulting unit is what over what?
Well,
Seconds over hours.
Miles over hours. In other words, miles per hour. So when you go to calculate, whatever is in the numerator gets multiplied. So parenthesis, 100 times 3,600, that's our numerator. Then you divide by whatever is in the denominator. Now, how many things do I need to multiply in my denominator? 2. So since there's more than 1, I need a parenthesis. There's more than one quantity, you know, the ones we can kind of ignore because multiplying by 1 doesn't change the number. So you do have to consider how you're going to type this into the calculator. If you type it in wrong, it's not going to come out with the correct answer. What do we got? This one?
22.807487. So just 22.8.
Anyone else get 22.8?
Oh,
That's your Brendan?
2.2.
wait, wait. Is he sitting there? It's okay.
So this is his speed over the entire 100 meter. That doesn't mean during that he could go a little bit above and a little below. Okay, it's his average speed over the whole thing. Now, right out of the gates, he's probably going to accelerate out of the gates, and then have his peak speed somewhere. I don't know, maybe towards the end. I don't know where you get to your fastest peak as a sprint runner in the 100 meter, but he's going to go above and below that during his race. So that's the average during his 100 meter.
So is that like a car,
That's how fast a car would have to go in order to keep up with him during his 100 meter. And I think only one person has sprinted faster than him, and that was very recently. But on these races, it's like by the millisecond. They don't beat them by a lot. So it's all very close.
There was one race where he it was funny, he was up here and everyone was back here. There was one.
Yeah, he is an extremely talented runner. Okay, so recall or just note, they're all
All of them?
ALL.
ALL.
All of them.